Okay, hi everyone. Assalamualaikum and greetings. Thank you for enrolling into our MOOC. All right, so for today's topic is about pharmaceutical solutions. And my name is Madam Sabiha or Madam Biha. You can just call me Madam Biha. All right, so let's start right away. Pharmaceutical solution are liquid preparation that contains one or more chemical substances, or what we call here the drug or active ingredients, which is dissolved in a suitable solvent. Sometimes it's just not just one solvent, it can be multiple solvent or co-solvents. We can use that as well. And these pharmaceutical solution, we can administer them through many route of administrations, either orally, topically, injection, and many more. So let's recap a bit on the term pharmaceutical dosage form. So I believe you have encountered this term before in probably learning activities, previous learning activities. So PDF, okay, pharmaceutical dosage form is basically the physical form of a drug which has been manufactured and administered to a patient. As you can see from the slide here, okay, we have a lot of dosage form. It can be in the form of tablets, capsules, cream and ointments, powders, solution, suspension, suppository, and many more actually. Okay, so route of administration basically referring to the path of a drug substance, medicinal product being administered into our body. So it can be through oral route, through ocular, or through the eye, through injection, nasal, vaginally, rectally, and as I say, many more. All right, so these are some of the example of route of administration. You don't have to remember, but it's good for you to know that we have a lot and variety of route. We have oral, sublingual. Sublingual basically is under the tongue, okay? Pulmonary, okay, through the lung, rectal, vaginal. Conjunctival means that through conjunctiva, intraocular means to eye, okay? And there's a lot of dosage form that can be administered into one route. For example, as you can see here, oral, we can administer solution, tablet, capsules. And for rectal, we can also administer many dosage form, solution, ointment, suppository, and so on. All right, so for pharmaceutical solution itself, it can be subdivided into two, internal and also external. So what is internal solution? Basically, internal referring to the drug as it in the form of solution being administered into the body system. So this include oral solution, mouth throat solution, and any solution that is being instilled in the body cavities. As you can see, this is the most common one you can see in the pharmacy. All right, so this is the syrup, paracetamol syrup, loratadine syrup, suspension. So they are categorized into internal solutions. All right, so what about external solution? So if internal solution means that we administer into the body system, external simply means we use on the body surface. Right, so this is some of the example. Lotion, colloids, and creams and ointments. So what is actually solution? Solution, as I mentioned previously in my first slide, if you could still remember, it is actually defined by the addition of a solute or what we call as active ingredient or the drug, and we dissolve them into a solvent or suitable solvents. It can be mixture of solvent, but they have to be mutually miscible solvents. And speaking of solution, we usually use the term solubility. So a solution has to be homogeneous, means that it only exists in one phase. Means that if you mix the solute and also the solvent, it has to exist in the form of one solution only. Means that if you shake them or if you leave it after a while, it won't phase out. Okay, as you can see here, this is the picture. Miscible simply means that the ability of liquid or the ability of the solvent and the solute to mix together to form bonds. So usually they can form bonds and produce a homogeneous solution. So this is an example of an ACl. An ACl is salt. Added into water, it's going to be a salt solution. And we couldn't see the salt at all. So it means that it is a very homogeneous solution. So for example, if we add water and also an alcohol, and we add them together, and we can see they can phase out. However, within time, if you shake them together, they can mix together and form a soluble or a homogeneous solution. This is still what we call as a miscible solution or miscible solvent, and it can happen as well. All right, so I've mentioned about solubility. Basically, it refers to the ability of a substance to dissolve in a solvent. So if we only requires a small number of solvent to dissolve 1 gram of solute, means that the solute or the active ingredient is very soluble in that solvent, right? So this is the solubility, the references that you can use to look at the solubility data for each medicinal agent, right? So you can just see if, for example, if you want to find whether a paracetamol is soluble in water or not, or in other solvent, they are stated in these references. So normally we use Martindale or British Pharmacopoeia, and some in the US region, United States region, they would use USB. All right, so this is just an excerpt from the one of the references. As you can see, paracetamol, it says here the solubility is soluble in water, means that 1 in 70, and 1 in 20, 1 in 20 at 100 degree if it is boiled, means that you only require, what does this mean? Okay, let's look at the definition below. 1 part of paracetamol is soluble in 70 part of water at room temperature, means that you would need 70 part of water to solubilize 1 part of paracetamol. And if you heat up the solution, it would solubilize much faster. And we know that solubility is much dependent on the temperature. So if we increase the temperature, the solubility would increase as well. So there's another information here. Okay, ethanol, you can see a lot more of solvents that paracetamol could dissolve in. So let's say in ethanol, it only requires 7 part of ethanol to solubilize 1 part of paracetamol. So means that if you compare between ethanol and also in water, which one paracetamol would solubilize more? Definitely it would be ethanol. All right, so what do we have in an oral solution? So this is an example of oral solution, gabapentin oral solution, 250 milligram per 5 ml. Simply means that in 5 ml, you're gonna get 250 milligram of gabapentin. Okay, so liquid medication definition, taken by mouth, active ingredient dissolved in a suitable solvent, and there are many advantages for oral solution, convenient, palatable, suitable for those who have difficulty swallowing tablets or capsules. And the formulation is always simple. We have the API, active pharmaceutical ingredient. Okay, if you have never heard of API, basically this is the component of a pharmaceutical drug that produce the therapeutic effect. So in simpler word, basically this is the drug that is responsible for giving the therapeutic action or the desirable pharmacological effect to your body. All right, so we have API and another one is solvent, and Most of the time, we would add excipients or additive, and this will make an oral solution. So as you can see from the example here, I'm so sorry. Okay, let's go back. Let's go back to the previous one. How to do this? Okay, never mind. Let's just move on. So, API, like I said, the main drug chosen for the intended use of the preparation. Solvent, the medium whereby the drug is being dissolved, such as water, syrup, or alcohol. And excipients is substance that is being added to improve physical chemical properties of the API, meaning that it maintains the stability, palatability, and all, in other properties of the solution. Okay, so this is the function of adding additives or excipients into our formulation. So most of the time, because we want to make sure that the stability is not being compromised. So physical stability means that the solution has to maintain clarity, color, or the taste and viscosity over their shelf life. Chemical stability means that the active ingredient is always stable, not undergoing any kind of chemical interaction. For example, oxidation, hydrolysis, photosensitivity that could degrade the active ingredient. And we want to make sure the solution is always not prone for contamination, bacterial contamination. That's why we have to add preservatives as the additive, right? Okay, so this is an excerpt from a YouTube video on a simple compounding preparation, extemporaneous preparation of a simple syrup or a simple medicinal product solution or a solution. All right, we can just try to play the video. So this syrup should make, all right, you can just look at this first. All right, so that's basically it. Um, okay, I think this is the simplest. Okay, all right. So I think this is the simplest video made by. I'm not sure actually. But as you can see here, I hope you understand or you can see the process of how to make or how to compound a solution or a solution based on the prescription given here. So this is the prescription, right? Syrup trimethoprim 5 milligram per kilogram BD for 10 days. So BD is twice daily, right? So this is the process, okay? The process of how to make the oral solution, okay? All right, so this is an example of oral solution, which is gabapentin oral solution. All right, so the active ingredient here, as you can see here, this is the list, okay, just below the picture of the bottle here. Okay, what gabapentin contains, it says here, active ingredient is gabapentin. 1 ml contains 50 milligram. And the other ingredients are the additives or the excipients. So active ingredient, as you can see, is gabapentin. All right. So 1 ml contains 50 milligram, which also correspond to the label in the picture here. 250 milligram in 5 ml. All right. So sweeteners, as you can see in the description, sweeteners. Obviously, this is the sweetening agent. All right, and another sweetener is saccharin sodium, and preservative normally are the methyl, anything with parabens, methyl, ethyl alcohol type of ingredient. They are the preservatives. So preservatives are basically the agents being added to slow down or to prevent microbial contamination. So what about solvent? Solvent is basically the liquid that dissolve the active ingredient or other excipients to form a homogeneous solution. So in here, the main solvent used is propylene glycol, and propylene glycol can also act as the preservatives. Okay, so they are used as solvent and also as the stabilizer. And another one is thickening agent. Carmella sodium, usually thickening agent is to increase viscosity of the solution, just to make sure that it is easy to pour the solution. You can imagine if the solution is not viscous enough, it will just runs out from the syringe or from the teaspoon that we use to measure the medicine. And then we have flavoring agent to add on the flavor to the solution. Obviously, we know that syrups or oral solution are mostly given to those who are not who don't like to take tablets or capsules. They don't prefer those formulation. So we put in flavoring agent to increase the palatability of the syrup or oral solution. And last but not least, we have the vehicle. Vehicle basically is the main solvent. Okay, normally we add a vehicle to make the finalized volume of the oral solution or the product. Okay, so these are the terms that we normally use: solvent, vehicle, and diluent. All right. So solvent basically it is the one that we use in dissolving our active ingredient. Okay, and then vehicle is the main carrier or the base of the drug. Normally it is the purified water. Okay, and diluent, we want to increase the volume of the solution. So usually normally this term can be used interchangeably and carry the same meaning. For example, vehicle and diluent, sometimes they are, the term is the same. Sometimes we say purified water, we add as the main vehicle, or we add as the main diluent, just to add on the volume of the medicine. Okay, so these are some of the oral solutions that is available. We have Linctus, elixir oral drops. Okay, we have many more, but these are some of the examples only. Linctus, most of the time they are used for cough relief, and they are intended to be sipped slowly. So normally for pharmacy student, we always advise them to counsel a patient to take Linctuses by sipping them slowly, and make sure that um, they uh, they run through the throat. Okay, just to make sure that irritation around the throat area is soothed out. Okay, and what about elixirs? Elixirs, most of the time they contain a higher concentration of alcohol as compared to the other type of oral solution. Um, and oral drop, normally they are very concentrated liquid medication, and used by administer a small amount of oral solution. So these are some of the pictures, and I believe many of these products are available in the pharmacy. So regarding the packaging requirement, we always remember that plastic or glass bottles are commonly used for packaging oral solution. We can use amber glass bottle for light sensitive medication. So these brownish color bottles is what we call as amber bottles. It can be in the form of glass or plastic. Okay, but normally what you always see is the left-sided picture, plastic bottles. More commonly seen nowadays and being manufactured in this packaging. All right. So this is the labeling requirement for compounded products. Uh, Essentially, we need to have patient information. Okay, this is the example of the bottle. So for internal label, okay, we put outside of the bottle after we finish compounding, and this is the example of the label. So for internal label, it has to be in black in color, but for external label, it has to be in red color. All right. So as you can see, we need to have this information, and they are a requirement, mandatory. Okay, number one is patient information. All right, as you can see here, the patient names is Abu, and also the ID, RN. And then the product has to be in the form of generic name, labetalol syrup, and the strength. Strength is 10 milligram per ml, and the volume of the preparation is 50 ml. Name of the product, and then we need to have the instruction on how to use the product. For example, in here, take 5 ml 2 times a day, and do not use after 4 weeks. So normally for compounded product, we don't keep it more than 1 month, right? Expiry date is also very important, and also when did you do the when did you do the compounding, right? So normally it is 14 days. Sorry, it is 4 weeks, but it can be lesser than that if you add preservatives. Okay, so this is the process of compounding pharmaceutical solution. For example, this is the prescription given to you for a patient named CC. All right, so the prescription is for is to compound loratadine syrup 5 milligram OD. OD is once daily for 6 days. So patient has to take loratadine syrup, which is an antihistamine, for 6 days. So the indication is flu. All right. So remark here, it says as loratadine syrup is not available, you need to prepare it by using tablet loratadine 10 milligram. Okay, the strength of the final preparation should be 5 milligram per 5 ml. So this is the final strength, means that we have to make sure that this strength to be put inside of the label after we finish compounding. right? So what are the steps? Number one, you have to do dose verification, all right? So patient was required to take 5 milligram OD, and we check whether the dose is suitable for CC. So previously, as you can see, CC is, okay, seems like I cannot go back. So CC is child of 2 to 11 years old. All right, so we look at the BNF. I hope you have your own BNF, British National Formulary. And then we refer here, loratadine should be given to child 2 to 11 years old, 5 milligram OD daily. So whether the dose is correct, yes, it is suitable. Okay, we can comment that the dose is correct for her. Okay, so we don't have to do any modification to the dose, and then we just have to calculate the amount of tablet needed to compound the syrup. So we were given tablet loratadine 10 milligram, right, from the prescription previously. So this is the dose, 5 milligram times once daily times 6 days, 30 milligram in total for the whole regimen. And then we divide by the given strength of a tablet. So 3 tablets is required. And then we want to know how much volume, the final volume of the syrup that we have to make. So this is the final concentration given here, 5 milligram per 5 ml. So what about 30 milligram? You have to do the cross multiplication. Then we'll get X. So if 5 milligram contains in 5 ml, 30 milligram would contains in 30 ml, right? So the final volume would be 30 ml. Now, when we have done our calculation, and so we need to prepare our loratadine. So this is the steps to do it. Okay, I've given you the materials for you to go through. So basically, you have to crush the tablets in mortar into fine powder, and then you have to levitate the powder with small amount of syrup or any kind of solvent given to you, and add more syrup to make a paste, and then we can start to transfer this paste into a container, and then just use or rinse with additional syrup and then make up to 30 ml of volume. And we have to pick which container to use. So if these are the containers given to you, you have to know how to pick them. As I mentioned previously, we can use plastic bottles. So make sure that the volume, the container's volume suitable to your preparation volume. So in this case, we can take 30 ml or 45 ml, which is good enough to store our medication, right? So what about the label? When we finish pouring our solution into the container, then we have to prepare the label. Okay, you might try, you can try with your friends, but I'm just going to show you. So this is the label, right? So 30 ml is the volume of the product, and the name of the medication, and also the strength. So the strength follows the remark given to you, the patient name, and also the instruction. Make sure the instruction is correct. Okay, normally we ask the patient to take in the form of volume. We don't say take 5 milligram because they won't know. So we would say take 5 ml once daily for 6 days. And the preparation date is the day you compound the medication. And expiry date normally would be 4 weeks. Okay, and this is also can be paste, or you can just write keep out of reach of children, and also control medicine.